Hello my dear learners. In this video I am going to discuss you a very interesting function in the R programming language where you can easily do a OLS regression assumption test within a very second. So without wasting any time, let's get started. In this video, I am going to show you a fantastic function called GVLMA, which means the Global Validation of Linear Model. Now here is a paper, Pena and State 2006, where I found this particular function very useful for our learners. What this function do? This function in a linear regression, they test the basic assumptions of the linearity. What are those assumptions? Normality, heteroscedasticity and linearity. Okay, so there are 5 types of output global state or GVLM function gives. The number 1 gives the global state function or global state test. That test gives us the idea of whether this model is a good fit to go for the next level, so passes or fail of our model. In other words, we can say it's a functional form whether it is correct or not. Then the next one is the skewness. It also tells us whether our distribution normally distributed or not normally distributed. If it is not normally distributed, we need to check our sample size. Then it gives us the kurtosis, which measures the distribution, outliers and influential data. As you know that the outliers are the main cause of the biasness, and the linear function gives a lot of problem for this outlier issue. So the kurtosis will give us whether we have sufficient outliers, and then we will decide how to delete those outliers and rerun the model by looking at the kurtosis value. Then we have the link function where it says whether our model is misspecified and how we link these elements in the model assignment. So now my dear learners, in this particular case we are first open the RStudio, and remember in my previous videos I shared that whenever you open the RStudio, before opening any project you need to set your working directory. Go to the project and set your working directory. I have several videos on that. Please set the working directory first and then start doing your project. So first install the package GVLM. This is the package command. You first install this, but you can use the project one all assumptions OLS test. This is my R script name. You should open R script and then write down the line or scripts for the project. So first install the GVLM project and then the library GVLM, which means that you are asking this session to use this function, and then we are using the 4x4 diagram to look at the residual versus fitted, normality, scale location and residual versus leverage. These are the 4 graphs we would like to see. So therefore we are saying the write the make 4 row of 2x2. This is our command, make 4 rows for our visualization purpose. And then we are using the data car. This is the important and very interesting built-in R data set. Let's look at this data set. There are two variables only. One is the speed and the other one is the distance. You see the speed and the distance. This is the car data set built in the R programming language. Okay, so you just have to do is data cars and this will appear in your R session. Then if you would like to view the data set, you can always view the data set and then create an object. Here in this case I create the object mode. You can use any name in the object. Then I use the LM function. Okay, I use the LM function, linear model function. Distance is our dependent variable and we are regressing to speed is our independent variable, and we are using our data car. This is our functional form. There are several videos in my channel where I shared how to use the OLS regression command and all those things. Please have a look those as well. Now once I run this regression and then I make this command GVLM mode, which means this object. Okay, and then I would like to plot this. Once it's done, what information it gives us? Let's have a look at it. Okay, let me show you the important information here. So So let's see, this is our install package. Okay, these are we already understand. Now once we make the GVLM command function, it will gives you the information of the coefficients. Here is our coefficient is 17.59. so as you can see easily, this is our coefficient value, then this is the speed coefficient value, this is the intercept, and this is the coefficient value. So intercept value, coefficient value is given, and then the assessment of the linear model assumptions. Fantastic, right? The assessment of the linear model assumptions with only one single command, GVLMA, only single command. My dear learners, how fantastic is this, right? Then using this global test on 4 degrees of freedom, we can see that global state, you see the previous example that I shared, the first, whether our model is good or not. It says the assumption not satisfied, which means our model is still have some problem. Skewness, the assumptions not satisfied, so we have still some problem in the skewness, I mean the distributional problem. Kurtosis, acceptable, assumptions are acceptable, and link function, which means our functional form is correct, so assumptions are acceptable. Heteroscedasticity, assumptions not satisfied, so this is a very big issue, so therefore we need to correct those problems, right? So we plot it and we find these 4 graphs. Look at this diagram, the residual versus fitted. If you look at this diagram very carefully, you see that there are 4 important information we can get from 4 diagrams. First, we can see the residual versus fitted, and in here 23, 35 and 49, these are the 3 data set are the outliers. It may be the case for this reason the model is not satisfying all those assumptions, so we need to remove these outliers, and most of the data sets are with the fitted line, okay, but these are the extreme outliers, which in my opinion you need to delete those outliers in order to see whether your assumptions are in the right track. And if you look at the normality curve also very close to the diagonal line, so which means that your assumptions or your normal distributions are very close except 35, 49, these observations, okay. So except this observation, you see 35 and 49, therefore we almost there in a normal distribution pattern using the normal QQ plot. Same goes to scale location, you see 23, 35 and 49 outliers, it causes the problem in the model. And here also residual versus leverage, the same things are showing in the Cook's distance. So by looking at this 4 diagram, we can see the outliers, and remember my dear learners, outliers are the main cause for your model that is not going to allow the model to be fitted or satisfied the assumptions, the basic 4 assumptions. So what we have to do, we have to remove these 4 or 5 outliers. And how we can do that? Very simple. Let's see how we can do that in the R Studio. Okay my dear learners, now what we have to do, we just need to remove the outliers, right? That's what we will do in initial stage. So we follow the same things and we do not change any other scripts. These are all okay for now. Only thing that we changes here is the object, LM, the independent variable, and then we remove, you see the minus sign, and then 23, 35, 49. These are the 4 data we remove from our rows, okay. And therefore what we do, we remove those rows or remove these data sets and then make the command GVLM again and then plot it. Remember my dear learners, you see that there is another regression model we ran before, and this is not here because we are now running without these values. So just run one single regression, either this one or the other one in one single time, not do at a time, okay, one by one. First you check it and then do not use the previous model again, use the model with the removal of the data set like 23, 35, 49, okay, and then you run it, and now voila, we can see that our assumptions are now getting corrected. You see the assumptions, if you look at the assumptions value very carefully, and we can see that our global state says the assumption acceptable, assumptions acceptable in the skewness, assumption acceptable in the kurtosis, link functions are also acceptable, and the heteroscedasticity also acceptable. So our 4 basic assumptions of the OLS linear model assumption tests are in order. And if you look at the residual versus fitted plot again, now only two values are outliers, 22 and 35, and most of the 39, most of these are now almost in the line with the fitted line. QQ plot are also very close. The Cook's distance are also only one outlier, we can see 49, and Cook's distance is the distance from the outlier and the fitted line, or the value and the fitted line. So the higher the Cook's distance from the observation to from the fitted line, this is a bad thing. So we need to lower the Cook's distance. Always look at the lower value of the Cook's distance of your outliers. Okay, if the values gives you lower value in the Cook's distance, then this is a good value and you can use it in your model. Okay, so this is how you can run one single command GVLMA in R programming and test your fundamental OLS assumptions very easily. Now let's have a quick look in BlueSkyStatistics. Okay, my dear learners, as you know, the BlueSkyStatistics is a R GUI and I have several videos in my channel. This is a fantastic drag and drop free software using for R programming. If you do not like to type R script or R code, this BlueSkyStatistics software is for you. So all you have to do, download this software, and I already shared the video previously where to download and how to download. Go to BlueSkyStatistics.com and it will allow you to download the latest version 10. Download it, install it in your computer, and this looks like this, the interface. Once you download it, there are a lot of options here, and I'm not going to go deep into the matter today because we are only focusing on the GVLM function. You can see and look at my other videos of the BlueSkyStatistics. There are several videos in my channel in English, so you can have a look and learn the BlueSkyStatistics use. But for now, the BlueSkyStatistics have the R editor as well, as you can see here. All you have to do, draw this 3 dotted line and then install R package and write down the GVLMA and then press the run. This run button, whenever you press, it will execute the button and it will successfully install your package, which you can see in the right hand side of my window. So once it installed, and then you write down library GVLM in your R editor, you see R editor in the BlueSkyStatistics at the bottom, and then it will library GVLM just like the R Studio. And then I use the make 4 rows for my visualization purposes, residuals and fitted, and then I use the data of the card data, built-in data in the R programming. Same command for the R Studio and BlueSky here, same command, and you can see in the BlueSkyStatistics the same way. It gives first not satisfied, assumptions are acceptable, and the last one is not satisfied. Same curve are giving here like the one in the R programming. Now what you have to do, you remove this part, okay, remove this line, and then as I told you, run again without the outliers. So run the outliers, just press this, click this one, and then you run again GVLM with the removal of the outlier. And as you can see here very carefully, that like the R Studio, that one that we have seen earlier, here also the assumptions are acceptable. Okay, just like the R Studio. Okay, BlueSkyStatistics is a fundamental and fantastic platform using R Studio as functional ability and as well as drag and drop options, just like any other software. And this is the wonderful software because it is completely free. Okay, and now again, if you would like to plot just like the R Studio, the one that we have done, okay, plot the mode again and you execute. You see the plot are given here, same information given using the BlueSkyStatistics. Once you've done it, you just have to export the output. You click the export the output. I would suggest you to click it in the HTML format, name it, okay, the OLS assumption projects, okay, OLS assumption test projects using GVLM, one single command, and you get all the information. Okay, and then what you can do, go to the desktop. Okay, you see the desktop version where we have one project, and look at it. Install R package, R script, BlueSky results. Okay, look at the value. It's fantastic, right? Look at the value. You see, look at the value. Everything is there. Very nice, right? The BlueSkyStatistics result. Then if you click Control and P, which means the PDF version, Microsoft Print version PDF, and then you just press print, and this will allow you to make a PDF. So now you name it like test 111 as a PDF. Let's say I would like to I'd like to save it in the desktop. You have a PDF version of from the BlueSky format output in a PDF format. You print it out and submit to your any lecturers or professors as a part of your assignment. You see, BlueSkyStatistics give you everything that you need in a PDF format from the BlueSky output. So you can use this BlueSky export output once you've done it, and then also you can use it RStudio platform, and finally you can be very happy with OLS assumption test in one single command. You do not have to use any other command to check the 4 fundamental OLS assumption. Next time, thank you so much my dear learners. I will see you in the next tutorial. If you like my effort, do share with your friends in the social media and give your comments in the description box, under the description box of this video, whether you understand it very well or you need any help. Thank you so much. Bye bye.